We have a sketch below of a function and we're asked to determine what a possible degree might be for it. So if we look here, we see there's 1, 2, and 3 local maxes and mins. Therefore, remembering that the degree of a polynomial is always at least 1 higher than the number of local maxes and mins, a good guess for this one might be a degree of 4. So we could say a fourth power. We don't know what the rest is or if there's a coefficient out here, but that's kind of what they're looking for. Then we also could consider that fourth degree power, remember end behavior. If the arrows are pointing in the same direction on both ends, as x values go really large or really small, then it would definitely be an even degree, like a parabola, an x squared 2 degree has the arrows going in the same direction, whether up or down. Now we need to find and estimate the zeros. So zeros are where it crosses the x-axis. So right here would be a 0, and we would say that looks like it's -3, 0. The next one over to it looks like -2, 0. And then the last one right here would be a 5, 0. Local maxes, those are the ones at the very top, so this arrow right there, that local max we could estimate to be 2, 4, we could say. Just making sure you know what those terms mean here. Local mins, this one will be a little tricky. How about -2.5, -1, something like that is fine. And again, they're all in coordinate form because they're all a point on the graph. And then here's a min, a local min also, so we would say that's at 5, 0 also. Finally, create a possible equation for the function based on the zeros in the end behavior. Well, we discussed how it's an even degree for sure because the arrows end up in the same direction. Then we also know the zeros of the function, we gave them here. So using those, we would conclude that an equation could be something like this. X plus 3, and that's because of this 0 right here, -3. If you put -3 into this equation, plus 3, you get 0, so that would make our point fit. We could go times x plus 2 in the same fashion, because -2 doesn't make our equation 0, and then also x minus 5, because putting 5 in for this equation, 5 minus 0 would make this go to 0, therefore 0 times everything will become 0. And we want when you plug in 5, the y value come out 0, so this would do that for us. Now when you stop right here, you might think this is the equation, but this would be the first, this x to the 1, this x to the 1, and this x to the 1. We know that you add exponents when you're multiplying. So this would give us an x to the third, and we already discussed how it has to be an even power by the end behavior, and we're thinking it's a fourth. This guy right here gets a second power. That's because we need another degree, and we call this a double root. Remember, if the function hits a 0 but bounces off of it, it doesn't go through, therefore preventing another 0 to happen. That would give us our quartic. So when it doesn't go through at a 0 and to the other side of the x-axis, we counted a double 0, so we would put that 2 on there. Now this won't be a perfect equation, but this could be a possible equation based on the zeros and the end